notes. First, we're going to start by talking about prime numbers and what prime numbers are, but thankfully you all already know that. So, prime numbers. Prime numbers. A prime number, and we've learned about primes since the beginning of the year on the calendar, is a positive integer, so it has to be something positive, and an integer is any positive or negative number, is a positive integer greater than 1 with exactly 2 factors. So a number that only has 2 factors, and what would the 2 factors have to be? Yep. 1 and the number itself. What are some prime numbers you all know of? Give me some prime numbers, Bryce. Yeah. 11, yeah. 11. Olivia? 23. Joe? 21's not prime. 7 times 3. 51, no. 50 divisible by 3. Lauren? 3, yeah. All sorts of prime numbers. Now, use your divisibility rules. Like 51 seems prime, but 5 plus 1 is 6, so you automatically know it's divisible by 3. So there's all sorts of prime numbers. Prime numbers are anything that only have 2 factors, one in itself. And we've learned about composite numbers before, too. A composite number, remember back to our calendar in September and October, is a positive integer greater than 1 with more than 2 factors. So it has to have more than 2 factors. Like 4 is composite because it has 1, 2, and 4. 8 is composite. 1, 2, 4, and 8. 12 is composite. 24 is composite. 51 is composite. There's all sorts of composites. But anything that has more than 2 factors. Everybody with me? Questions about prime and composite numbers? Prime and composite numbers. Okay, so today we're going to look at how to write prime factorization. Prime factorization is pretty simple. It's writing a composite number. So we're going to take composite numbers, and we're going to write it as product. Remember, product means to multiply. So we're going to write it as a product of its prime factors. So basically, we're going to find the prime factors of a composite number. So we're going to find the prime numbers that make up a composite number, and that is going to show the prime factorization, which makes sense because we're finding the prime factors, which is where prime factorization comes into play. Pretty simple stuff. Now, it can be a bit confusing, and you really have to know your multiplication facts. So if you struggle with multiplication facts, that can be challenging. So let's do 72. Let's start with 72 and we'll work from there. I call them factor trees and I call them leaves. Your leaves can only be prime. So in order to make something a leaf, it has to be a prime number. So somebody tell me something that multiplies to make 72. 2 numbers that multiply together and get you 72. 9 times 8. Just like that. Making my own factor tree. Can I circle 9 or 8? Are either of them prime? No. So I've got to keep going. Hence why it's a tree, because it just keeps going. So someone tell me something that multiplies together to get us 9. 3 and 3. Now, you didn't have to choose 9 and 8. You could have chosen 2 times something else. The only thing you don't want to choose is 1 times 72. That doesn't get you anywhere. That doesn't help you at all. So, you can choose anything you want. Questions up to this. Here we go. So, now, are 3 or 3, are either one of them prime? Yeah, both of them. So I'm going to circle them because I can't go any farther. So they become leaves. They become leaves. And now, I go on to 8. What times what makes 8, everybody? 4 and 2. Are either one of those prime? Yes, 2. So I circle the 2. And now I have to keep going with the 4. So the 4 is 2 times 2, and both of those can become leaves. You can't stop until all you have left is leaves. If you come to a number that's still composite, you have to keep going. You can't stop till all you have is prime numbers left. So then, to write the prime factorization, you've got to write all your leaves out. And I write them in order. So I write them in order from least to greatest. So I'm going to write down 3 2s. 1, 2, 3. And it's the product, so we're multiplying them times 3 and 3. And if I was to multiply that out, it should get me back to 72. If not, I haven't done it correctly. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 3 is 72. So it works. So now, the prime factorization is just 2 to the third power and 3 to the second power. That is the prime factorization, because it's the prime factors of 72. Does everyone understand that? Pretty simple stuff. All right, let's do 121, because 121 is one of those ones that can kind of throw you for a loop. Does anyone know what multiplies together to get you 121?
11.
Yeah, 11 times 11. What's the funny thing about 11 and 11? They're both what? Prime. So this one's easy. So the prime factorization of 121 is 11 times 11, or 11 to the second power. 4 squared, yes. You guys try B and C. You all try B and C at your table with your partners.
Yes.
You could have done this either, like, there's multiple ways to do it. I'm going to show you the way I did it, but as long as our end prime factorization is the same, it doesn't matter. As long as at the end we have the same prime factorization. So for 225, I did 25 and 9, which neither one are prime. So then I said 5 times 5, both of those are prime. And then 3 and 3. So my final answer should have been 3 squared times 5 squared. You always want to order from least to greatest. If you left it like this, that's fine. It's just not in simplest form. You always want to try to take it simple. All right, the next one, you could have done 3 times 100 or 30 times 10. I did 30 times 10. And then I did 3 times 10, 3 being prime. And then I did 5 and 2. And then I did 5 and 2 again. So this one I had 3 times 2 times 2 times 5 times 5. Or 2 squared times 3 times 5 squared. Either answer is correct. It doesn't matter how you get there. It doesn't matter how you get there. Are there questions? So now we are going to look at finding the greatest common factor using prime factorization. It is super simple, but you can easily overthink it. So as soon as you overthink it, you're making it not so simple. Okay? So we're going to do 2 together, and then I'll let you try the 3 at the bottom yourself. So find the GCF, greatest common factor, that's what that means, of 40 and 60. This is super easy. What you're going to do, you're going to do the prime factorization of 40. So you want to do the prime factorization of 40 and the prime factorization of 60. So do that right now quickly. Prime factorization of 40, prime factorization of 60. I'm going to do it up here if you feel like you need a little bit of help. Don't take up the whole space because you're going to need it here in a second. So now, all you're going to do is it says find the greatest common. Common is the word you need to think of. Common factor. So you have to figure out what they have in common. So, let's think about this. Do they have a 2 in common?
Yes.
Yes. They have a 2 here and a 2 here. Perfect. Do they have another 2 in common?
Yes.
Okay. Do they have another 2 in common?
No.
No. Do they have a 5 in common?
Yes.
Do they have a 3 in common?
No.
No. You only take what they have in common. So they have 2 2s in common and a 5 in common. Everybody with me? Everybody understand that? Because this one doesn't have the third 2.
Oh,
Good question. So we have 2 2s and a 5. So the greatest common factor is 2 times 2 times 5. Everybody with me? Anybody confused? So the greatest common factor is 2 times 2, which is 4. 4 times 5, which is 20. So their greatest common factor is 20. Pretty simple stuff. That's all you do to find the greatest common factor. Questions about finding the greatest common factor? Let's try this one. This one's different. This one's more algebraic. Find the GCF of 6a to the third b and 4a to the second b. Okay, you're going to ignore the variables till the very end. You're going to ignore the variables. So all you're going to do is find the prime factorization of 6 and 4. So right now, do the prime factorization of 6 and 4. This should take you about 30 seconds. Okay, hopefully you got this. Those should not have taken very long. Now what I'm going to do is I'm going to reinstate the variables. So this is a to the third, so I'm going to add in a times a times a times b. I'm going to put the variables back in. And then this one, it's going to be 2 times 2 times a times b. I'm just expanding the variables. Does everyone understand how I did that? All right. So now, all you do is find what they have in common. Do they have a 2 in common?
Yes.
Yes. Do they have a 3 in common?
No.
No. This one has 3, but this one doesn't. Do they have an A in common?
Yes.
Do they have another A in common?
Yes.
Do they have another A in common?
No.
Do they have a B in common?
Yes.
Do they have a 3? No. Do they have another 2 in common?
No.
No. So the greatest common factor is 2 times A times A times B. Or 2A squared times B. Whichever way you like to look at it. Both answers are correct. Questions on that one? Yes, sir.
You when you wrote it out, we add there like 2 times 3a.
Sure, you totally can, but then, so you should complete the bottom 3 and bring those to class.